Alright, so on the back of our iron card we have our friend the flowchart, and this flowchart can help us name many of the compounds that we will encounter throughout the year in college chemistry. Are there compounds that are exceptions to this rule? Yes, indeed there are. However, I will try and pick as many as possible that fit in this flowchart and can be named this way. So a flowchart, again, it's a series of yes or no questions that can help you solve a problem. So here our problem is going to be, how do I name a compound if I'm given a formula? Well, the first question that you see there asks, is the first element in the compound hydrogen? If that is the case, then we have an acid, and your friend the flowchart gives you an example over here. So HNO3 is nitric acid, and remember in your notes packets we have some of the common acids and their formulas that can fit into answering that question. So I may ask you a few of those, but for the most part, when we start answering using the flowchart, we're going to start mostly here. Are there more than two different elements in the compound? Now what that means is how many elements are found in the compound, not the numbers per se, but different elements. So we looked at sodium hypochlorite before, and in sodium hypochlorite there are three elements. There's sodium, oxygen, and chlorine. So there are three elements that make up that compound. So if I was looking at this question, I would say yes, because there were more than two different elements. Some other things to notice before we check it out in action. We should know the difference between a metal and a nonmetal. Remember, on our periodic table there's that staircase. The majority of our elements are metals. The nonmetals are predominantly found in the upper right-hand corner of the periodic table. And we also want to make sure we know what an A element is. And if you look at the front of your flowchart, your super friendly ion card, we remember that we have A and B sections. The top chart shows us the representative A elements. An A element essentially means that it will only form one kind of ion. So all these in the first table are definitely A elements. When you look at the second table, that's why there's a large B there. These elements form more than one type of ion, and most of these are found in the middle section, the transition metal section. But any element that can form more than one kind of ion is labeled a B element. And that third little chart, silver, cadmium, and zinc, they're also A elements because they can only form those one ions. So let's look at our flowchart in action. So I took 4 of these examples from your Name That Compound worksheet. The first one there is C5O2. So looking at my flowchart, is the first element hydrogen? No. So I go to the next part. Are there more than 2 different elements in the compound? Again, there's only carbon and oxygen. Doesn't mean 5 plus 2 is 7. Carbon and oxygen are the 2 elements. So there's not, so I am going to go no. And when I go to the side, you'll notice this friendly little bubble. The compound is binary, and that just means there's 2 types of elements in it. The name is going to end in "ide." So every time we go to this side of the periodic or of the flowchart, the compound name is going to end in "ide." Is the first element in the compound a metal? Is carbon a metal? No, it is not. It's in the upper right-hand corner of the periodic table. Carbon, coal, not a metal. So now we see that this compound is molecular, and we're going to use our prefixes in the name. So the prefix for 5 is penta. So over here I have pentacarbon, meaning 5 carbons. The prefix for 2 is di, so it is di, and then again, all compounds end in "ide, so oxygen becomes oxide. So this is pentacarbon dioxide. Let's look at this one, Al2S3. Is the first element hydrogen? No, so we're going this way. Compound is binary, name ends in "ide." is the first compound, the first element a metal? Aluminum, yes, is a metal. Aluminum cans. So now we get to the, do we have an A element? So I have to check my super friendly ion card. And when I do that, lo and behold, here is aluminum right there in the A group. So it is an A element. So now it says just name the ions. So aluminum is the aluminum ion when it's positive, so that's aluminum. And then sulfur becomes sulfide. So this is just aluminum sulfide. Our next example is CrCl3. So I've got chromium and I've got chlorine. So again, no to hydrogen. There's only two elements. We're still binary, still ending in "ide." Is the first element a metal? Chromium. Might think of chrome bumpers, but yes, chromium is a metal. It's a transition metal in the middle of our periodic table, number 24. So yes, it's a metal. Is it an A element? Well, again, we have to check our super friendly ion card. And when we do that, we see chromium is down here, and chromium is in the B section. So it is not an A element. So when I come back to my flowchart, I have to name the ions, but I'm going to have to use Roman numerals or a classical name for the metal, because chromium can be more than one kind of ion. So this is definitely chromium. I need to give it a Roman numeral. And then chlorine, we're still binary, it's ending in "ide, so this is chloride. So how do we know which chromium it is? And you might think, oh, well, I can see the 3 in the formula. And a lot of times that is going to be the case, but the official way that we figure out the Roman numeral, we'll always know the negative ion. So chloride is always -1. And I know that. I can see that on my super friendly ion card. Right there, chloride, -1. There are 3 of the chlorides. So -1 times 3 means that this side of the formula is -3. Well, remember, when we write ionic formulas, they always have to equal to 0. So if we've got a -3 part, then the chromium over here must be +3 to make the net ionic charge of 0. And so this is chromium 3 chloride. Sorry, my ones aren't that great. But so we know that we're using the chromium 3 ion, so this is chromium 3 chloride. Again, you say, okay, I see the 3 there, and that works a lot of the time, but not all the time. So checking the negative charge of the compound will guarantee to know what the positive side is. Alright, our last example, CaS2O3. So here, again, first element is not hydrogen. This time, there are more than 2 different elements in the compound. My compound has calcium, sulfur, and oxygen. So I'm going on this side now, and my little bubble says, hey, this compound contains a polyatomic ion. So I will have to be aware of that. Well, once we get to this side, the first question says, is the first element an A element? Is calcium an A element? So when I check on my super friendly ion card, calcium's right here. Group 2, definitely an A element. So when I look back at my flowchart, I just have to name the ions. So again, calcium, and then I have to recognize S2O3 as being a polyatomic ion. And so that S2O3 is what we call thiosulfate. And so this compound is calcium thiosulfate. So those are some examples for naming of the compounds. I hope that helps. You can pause the video now, and I will show the rest of the answers for the name that compound worksheet, so you can see if you did them right. So here's the top half of the name that compound, and we can see the ones that we did together: pentacarbon dioxide, aluminum sulfide, chromium 3 chloride, and I forget where the other one is. Sorry, that's down a little further. But these are the answers. You can see I highlighted a couple things. I highlighted the polyatomic ions. Hopefully you recognize those correctly. Chromium, tin, and iron, those three were B elements, so all three of those needed us to figure out which ion was being used. And so hopefully you figured that out correctly. Just as an example, down here, selenide is always -2. So 3 of those makes -6 on that side of the compound. So this side must be +6. And since there's 2 irons, if I divide the +6 by 2, that means that each iron has to be +3. So that's why it's iron 3 selenide. The bottom half is here. And again, a couple highlights. Cobalt is a B element, so I needed to figure out the 3. And over here, lead. This is lead 2, and this is lead 4. Because, sorry, gotta grab my pen. Nitrite is -1, so with 2 of them, I need the +2 lead. But on this side, sulfate is -2. And since there's 2 of those, that makes a -4 total, which means this lead has to be lead 4, +4. And at the very bottom, you can see I threw in an acid. There's sulfuric acid because the first element was hydrogen. And I think that pretty much sums up the rest of them. Hopefully you got them right. And if you didn't, make sure you check with me. Alrighty.